In this video, we'll look at what it means to be a solution to a differential equation. But let's begin with a simple algebraic equation, 4x minus 2. And suppose we wanted to know whether 5 is x equals 5 a solution to this equation. Now, of course, you may be compelled by your past experience to just solve this equation to answer this question. If we really want to know just whether 5 is a solution or not, all we really need to do is substitute 5 for x and see if we get a true statement. So in this case, we'll put in 5 here for x minus 2, and we're wondering if that's equal to 10. And let's see, 4 times 5 is 20 minus 2 is 18, which is not equal to 10. And so our conclusion from this is that 5 is not a solution. Okay. Suppose instead we wondered whether 3 is a solution. We could substitute 3 in here. And I'm going to do it in a slightly different manner that will show what we're going to do when we work with differential equations. This equation has two sides, a left-hand side and a right-hand side. We're going to let LHS stand for left-hand side. So the left-hand side, when x equals 3, so let me put up here x equals 3. The left-hand side will come out to be 4 times 3 minus 2, which is 12 minus 2, or 10. And then the right-hand side of the equation is just 10. So because the left-hand side equals the right-hand side, x equals 3 is a solution. So that's the technique we're going to use with differential equations to see if something's a solution, is we'll substitute our proposed solution into both the left-hand side and right-hand side and see if we come up with a true statement, or if the left-hand side equals the right-hand side. So let's begin with this example. Let's suppose we ask the question, is y equals 5 cosine 4t a solution to the differential equation d squared y dt squared equals negative 16y. Okay, so what we want to do here is compute the left-hand side of the equation, which is a second derivative. So before we can get that, we need the first derivative, of course. And so the fact that y equals 5 cosine 4t, gives us that dy dt is, remember the derivative of cosine is negative sine, so we'll have negative sine 4t, and by the chain rule, this 4 times the 5 gives us a 20 here. Then we can go on and find the second derivative, which happens to be the left-hand side. So the left-hand side is the second derivative, which is going to be the derivative of sine is just cosine. So the sign, this negative sign doesn't change, so we'll still have a negative. We'll have cosine of 4t. But we then need to take 4 times the 20, giving us 80. So that's the left-hand side. The right-hand side is equal to, in fact, I'll just put an equal sign here instead of a colon. Let's say the right-hand side equals negative 16 times y, which is negative 16 times 5 cosine 4t. And let's see, 10 times 5 is 50, 6 times 5 is 30, so 5 times 16 is 80. So that's negative 80 cosine of 4t. So you can see that our left-hand side is negative 80 cosine 4t, right-hand side is negative 80 cosine of 4t. And so what that tells us is that y equals 5 cosine 4t is a solution to the second derivative of y with respect to t squared equals negative 16y, to this differential equation we have here. All right, so again, let me just recap. We take our function and we calculate any derivatives necessary to get the left-hand side. We compute it, we compute the right-hand side, and we then determine whether this is a solution. Now notice the difference between our algebraic situation up here and the differential equation. In an algebraic equation, a solution is a number. So the number 3 is a solution to this algebraic equation. When we're looking at possible solutions to differential equations, the solutions to differential equations are in fact functions or equations themselves that satisfy the differential equation. All right, let's look at one more of those on this video, and then we'll move to another video of more of the same. So let's ask the question, is y equals c e to the minus 2t a solution to y double prime plus 3y prime plus 2y equals 0. Okay, and c in this case is a constant. And the question is whether this, for any value of c, are there any values of c for which this is a solution to that equation? So you can see that to get the left-hand side, we need the second derivative and the first derivative. So y equals c e to the minus 2t gives us a first derivative of negative 2 c e to the minus 2t, and the second derivative is 4 c e to the minus 2t. So using those, then the left-hand side, which is y double prime plus 3y prime plus 2y, is going to be equal to 4 c e to the minus 2t plus 3 times negative 2 c e to the minus 2t plus 2 c e to the minus 2t. And you can see here this is going to give us negative 6 e to the minus 2t. There's positive 4, there's positive 2, so the result is going to be 0, which is in fact the right-hand side of our equation. So we can see that the left-hand side equals this, which then equals this, which then equals 0, which is the right-hand side. So the left-hand side does equal the right-hand side. Notice that it doesn't matter what c is. The c's just go away in the end. So for any value of c, y equals c e to the minus 2t is a solution to the differential equation y double prime plus 3y prime plus 2y equals 0. And that concludes this video. We'll go on in the next video and do more of the same type problem.